So hey guys, welcome to the Average Coder. Today we are going to learn about OOPS concept in C++, and for your info I compiled all the best resources available in YouTube or internet about OOPS in C++ and then make a detailed scope on it. So you don't need to find here and there, you will get all concepts about OOPS in one place. You just have to go through the note before your exam or your interview. This is a kind of cheat sheet which will help you to memorize all the concepts. So without wasting more time, let me explain you the topics of the note. So let's move on to our first slide. So at first you have to know why we will use OOPS. Here is a lot of theories written, you can read it later. I am just explaining you. Actually when CPP language was invented, it was called C with classes. That means you can understand CPP was invented just because of implementing OOPS concepts. So OOPS concept is very much important for programming. In OOPS we get a data hiding feature and the code becomes more manageable when we write a long code, and there are various more helpful features in object oriented programming. You can read it, and here's a lot of terminology written, so you don't need to worry about that. We will go through every topic step by step. So now move on to our second slide. So our second slide is all about access modifiers. So here as you can see there are three types of access modifiers. One is public, one is private, and one is protected. For understanding protected modifiers you should have a knowledge of inheritance, and we will also cover inheritance in our next slides. So for now just ignore this. Just focus on private and public modifiers. Here you can see that in driver code we are creating an object called average coder, which is of employee type, and we are calling the function of employee class. The function is in the public modifier section, so the function will be run successfully. As you can see, there is written also that this will print a public modifier is called, this line will be called, and but from driver code we cannot access the variables ABC. For accessing these variables we have to write some code, or we can just print value of A, B or C in this function. So just cout and I want to print A's value and A. So thus we can print private modified value, means the variables which are in the private section can only be accessed within the employee function, within the employee class. And for protected sections we have to create a child class, and here is a lot of things written here, so for now just ignore this. We will also learn it in the inheritance section. And here's a short note that there is written that if you do not specify any access modifiers for the member inside the class, then by default the access modifiers for the members will be private. Means if we don't written here public or protected, all the things we will written here will be private by default. So this is to our next slide, which is about classes and objects. I think you already understand what is classes and objects, but the definitions of classes and objects are written here. You can read it later, but the most important thing is what is the main difference between structures and classes. As you all know that structures are already available in C. So what was the need of creating classes or OOPS in C++? That is written here that we can hide data in we cannot, sorry, there's a mistake here. This will be we cannot hide data in structures. I will recheck it and I will correct it when I will provide you the code. And second point is we can write functions in and here's another mistake which will be cannot, that we cannot write functions in structures. Means when we initialize a class, there we can write a function very easily. We can hide data through private access modifiers, to protected access modifiers, but in structures we cannot get those features. And the main thing is classes make our code more manageable than structures. So some definition is written here, you can read it from here. And there's the syntax is written, the syntax to create an object dynamically. Means when we will creating an object dynamically, it is absolutely same as creating an object in normal data type, in normal variable dynamically. Suppose normally we written int a when we initialize a variable a of int data type, but when we try to initialize in dynamically, then we write int star a. The same thing is also written here, that at first we will write class name, then we will give a star and then object name and new class name. Thus we can create object dynamically. So that's all about classes. And let me explain this code to you. Here's a class is written called student. So in driver code we are creating two objects of this class. One is average coder and one is pro coder. So in average coder we are calling a function setter and we are giving value 13 and 20. So as you can see, when we will write this, and the setter functions is in public section, so we can easily access it from driver code. So in setter the 13 will be received in roll and 20 will be received in number. and this will store in roll number section. Means as I have previously said that we can access all the private variables easily. We can private variables easily from the public section. So we are simply doing that we are storing roll in roll number in marks, and here we are using a if loop. Means this function means this program is written that a programmer, a student is passed in exam or not. So it will check that marks greater than or equal to 34. Then input pass in grade, that is also a variable in private section. Else it just put fail on it. Okay. So thus we are providing the values for average coder and pro coder. And when we are calling getter function, here we will learn a new thing that we can also implement the functions outside the class, and this is the way. Means at first we have to give the void or it, which will be the return value of that function. Here this will be the void, and then we will write the name of the class, means in which class the functions actually lied. The getter function is in the student class, so we write the student, and we have to give these two signs, and then the function we can simply implement the function outside the class. So when we will plot getter for average coder and getter for pro coder, for average coder it will be roll number 13 fail the exam because he is the average coder, and for pro coder output will be roll number 1 pass in the exam. So now we will be learn about this pointer and constructor. Constructor will be discussed later very clearly. So for now, if we talk about this pointer, so what is this pointer? This pointer is used to retrieve the object x. X means a variable hidden by the local variable x. Means when we are calling these functions, average coder, means actually these things are called constructor. Means when we called a function with the same name as the class name, then when we just initialize the class, the function is also called automatically. This is called constructor, and this will be discussed later very clearly. Suppose you just think that this is a function which is called here, and you can see it that we are providing that the details which is name, it is the same as the details which are written here, means a variable which is private. So we just use that this pointer to differentiate between the private variables, means which is local variable hidden by the local variable, and the variable which we are providing. So this pointer just make the things very easy to understand that this means this means when we are creating this average coder, means these objects. So in that object also there in that specific object a variable is also created called name, which was blank. So when we are providing some details, it will store in that variable which is on the new object, which is called average coder. So more you will use it, the more you will understand the thing, and it will be very easy for you to understand. So let's move on to our next slide. And now you will know what is encapsulation. A proper definition of encapsulation is written here already, but in simple word, the process of data hiding means when we capsule the data in private part of any class, that is called encapsulation. So it's only a concept, not a very big thing. So now move on to our so now here's a very basic but important concept, nesting of member function. So nesting of function is absolutely same as normal nesting of functions a loop. So as you can see here, a function named check even is nested on set data function, and check even function is defined outside the class. I have already explained you the way how to define a function outside the class. So that's all. Now move on to our next slide. And one thing here, we use bitwise operator to check, means here you can see a bitwise operator is used to check a number is even or not, and you also should use bitwise operator more frequently because it's a very fast and inexpensive process to check a number is even or not. Means it's better than using those modulus operators. So that's all, and go for the next slide. So now static data member and function. So what is static variable? When a variable is declared as static, space for it allocated for the lifetime of the program, and after that if we call it for multiple times, as the space is allocated only once, so the value of that variable is previous call gets carried to the next function call. And you can see a very beautiful example of static variable in the screen. So now the same thing is happens here also. The difference is you just have to initialize the static variable outside of your class also. Means here you can see we also initialize the static variable outside the class in this process. and outside the class you can also initialize the variable with any number you want. Generally static variable initialize with 0 by default, but in here it is also written here that we can initialize count here with any number, which you can also initialize with 1. So that's all. And here comes the static functions, this one. So the simple definition for static function is it can only access the static variable, nothing more. So that's all. Now go for the next slide. Now friend function. So what is a friend? A person who has the access of your public as well as your private properties. The same thing also happens here. A function can be defined as friend function by just adding friend before its name. This is the way to tell the compiler that this print length function here, this print length function here is a friend of this rectangle class. So some properties of friend function is also written here, and we generally, the most important property is this one. We generally pass an object as an argument of a friend function, and you can see it here. For accessing the length of object B, this class must be the friend class of this rectangle class, means must be the friend function of this rectangle class. So that's why it is written here that friend in means the full orientation of that function, that it will return in. So this is in the name of that function and which kind of arguments it received. Here it's received object that is of class rectangle class type. So this is also written here. So this is the way to initialize the friend function. So now we will move on to our next slide, which is about friend class and friend and member friend function. I just simply explain this code here, what is happening here. At first, in the driver code, we are initialize a std object of type student ID. So where is student ID? This one. So at first we just initialize, okay, everything is fine. Now we are calling set data functions and passing 12 to it. So this will go to here, and this 12 will store in the private variable A. No problem. Now we will initialize another object named S of type std name, which is written here, and we also called the set data function of std name, and we provide average coder string here. So in this case, this average coder will be stored in this is also a private. We have already discussed that when we don't specify that it is private or public, then it is private itself by default. So it will store in a private variable name. So till now everything is normal. When we are calling print data function of object S, means which is a type of std name class, then means this function, when this function is called, we can see that this function is defined here. So we have also discussed this topic also, that how we can simply define the function outside the class. So this was the way, you already know it. So this takes two arguments. One is two objects here. One is of type student ID and one is of type student's name. So this function is a part of student's name class. So this will get these objects all access of all the variables of this object very normally, because this is a part of the student name. But for accessing the student ID, we have to make it a friend function of student ID. So you can see that it's written here. And here's one thing, I hope you all noticed here that this is initialized at first as class student ID. So why we initialized this at the top of the function? Because when this function was written, that print data function will take two arguments. One will be a type student ID and one will be a type student name. Then compiler will say, okay, fine, I know that student name is something, a class, so I already know that. But what is student ID? Because compiler will read the code from the first to last. For clearing the confusion of compiler, we just initialize the student ID class at the top of the function, and later we just completely define the whole class here. So that's all. Now move on to our next slide. Now we will discuss about constructors. A lot of things and definitions is written over here. In very simple word, a constructor means when we give the same name to a function and a class, then in the time of creating an object of that class, we automatically call that function also. So those functions are actually called constructors. So there's three types of constructor. First one is default. So in this type of constructor, no parameter is passed. We just have to make an object of a specific class, and the constructor simply called by that. And then comes parameterized constructor. You can see an example of parameterized constructor over here. This is the example of parameterized constructor, that we are creating an object, and here is a function with the same name of the class, and we are providing some details here. So it has parameter, so this is called parameterized construct. So copy constructor is a member function that initializes an object using another object of the same class. You can see it here when we are trying to assign num1 in num3, means over here we are trying to assign num1 in num3. This copy constructor is called, and one more thing here, when we use copy constructor, this is called deep copy. If we don't use copy constructor here, then also the code will not give any error, because we can, when we are simply using this assigning operator with this equal sign, in that case also this num1 will be copied to num3, but in that case this will be called shallow copy. Means in that case the pointer will be copied, not the actual memory it's pointing to. So the main problem will be that if after some time we make some changes in num1, then these changes will also be visible in num3. But when we are assigning something, we never want that if we want some changes, if we did some changes in a specific object, these changes will also be done on other objects. So we will not prefer this shallow copy, we always prefer deep copy. So for deep copy we have to make copy constructor. If we not make the copy constructor, then by default shallow copy happens, and I have already told you the problems of shallow copy. So the next slide you can see that the same things are written here about shallow copy and deep copy, and this is written in more detailed manner. So when you will access these PDFs, then you can simply read and go through this. So that's all for now. So now move on to the next slide. Now we will read about constructor overloading. So what is written over here? In C++, we can have more than one constructor in a class with the same name, and as long as each has a different list of arguments, this concept is known as constructor overloading. So what is written over here, that is, in C++, if we have two constructors with the same name, then our C++ compiler is smart enough to differentiate between them with the difference between the parameter. So here's an example that we are making an object of construct type O, and we are not giving any parameter here, and in the second case we are also making an object O2, which is also a type construct, and in this case we are giving some parameter. So our C++ compiler is smart enough, it will differentiate between these two and no error will come. In this case it will simply call this function, and in the second case it will simply call this function, which is two parameter. So there is some natures or some basic notes about constructor overloading. You can read it after pausing this video. We will move on to our next slide. So now we will read about destructor. So what is written over here? A destructor is a special member function that works just opposite to a constructor. You can simply guess it by its name, destructor. Unlike constructors that are used for initializing an object, destructors destroys the objects. So here is written that when a destructor will be called. So when a function ends, when the whole program ends, when a block containing local variable ends, and when we delete, when we use the delete operator, when a delete operator is called, then a destructor is called. So in this code we will try to understand this topic. So you can see it in the driver code. We are making an object named n1, which is of type num. So when we are making this, then this constructor is simply called, because this is the default constructor. So I think you already understand, you have knowledge about default constructor here. So this will be called, and here you should have another knowledge about static variables. We also covered this topic previously, so I hope you know that we have to initialize the static variables over here in C++. Means if we want to use static variables in class, then we also initialize in outside the class. This was the way. So when this default constructor is called, this will be printed constructor called for object 1, and the count will be, in this case, count plus plus, means the count will be 1. So now we are initializing a variable I with the value 2, and a while loop is called. So when the loop will run for the first time, then we will make two objects taken, n2 and n3. So again this line will be printed for 2 times, means for the first time when it will print that constructor called for object count 2, and when this will end for the first time, then this will be printed, that destructor call for object 2, and count minus minus means 2 will be 1, and again when the loop will start, then in n3 this will again be called the constructor call for object 2, and after when this loop is terminating, this destructor will be called, and after that, after completing this whole program, the point is written over here that when the program means the destructor is called, then the destructor will again be called for the num n1. So I hope you understand this. If you don't understand, then you can simply copy this code and you can run it on your compiler, and after seeing the output you can simply understand the way how destructor actually works. So that is about destructor. Now move on to our next slide. Now we will read about probably the most important topic in use, that is inheritance. So inheritance is an important pillar of object-oriented programming. As I told, inheritance is the process of inheriting the properties and behavior of an existing class into a new class. Means it is something. Means this is also written over here. It is something about parent-child relations. Means we will create a child class which will inherit some properties of the parent class. So there some terminology again comes that which is subclass. Subclass means the class that inherits properties from another class. It is called subclass or derived class. Means the child class is called subclass, and the superclass means the parent class is called superclass. So the class whose properties are inherited by the subclass is called base class or superclass. So now a point comes that why we will use inheritance. So the main advantage of inheritance is code reusability. Means we cannot there's no need to write the same functions, the same methods again and again. We can simply inherit some property of a specific class in a new class. So this is written over here. And the second point is the runtime polymorphism. It's a method overloading can be achieved by inheritance only. So now you will ask what is polymorphism, what is runtime polymorphism. So we will also discuss it after some time. So for now, just ignore it. So now comes modes of inheritance. This is probably the most confusing part, and most of the people just ignore this portion. So just follow me carefully that the first mode of inheritance is public mode. So if we using this mode, then the public part, the methods, the variables which was public in the base class will be also be public in the new child class, but the protected class members will become protected in the derived class. When we are using public, then the methods, the variables, the functions of the parent class will also be public in the new child class, but the protected class members will become protected in the derived class. And if we use protected mode, then the protected functions, the protected method will be protected, but the public methods, the public functions which was public in the child class will become protected, which was public in the parent class will become protected in the child class. And in private mode, if we derive a subclass from a private base class, the both public member and protected member will become private in the new child class. So that is, now move on to the next slide, which is about types of inheritance. So there's a lot of types of inheritance. First one is single inheritance, second is multi-level, third is multiple, fourth is hierarchical, five is hybrid, and sixth one is inheritance ambiguity. This is not a type, but you have to read it. So there's a lot of types, so don't be confused. Just these inheritance types are very easy to understand, so just follow me carefully. If we read about single inheritance, so in single inheritance, one class extends the functionality of another class. In single inheritance, there is only one parent and one child class. Means suppose a person is the lone child of his parents, means a single child of his parents. So this is called single inheritance. There's a very good example that we are creating a child class dog, and the parent class here is animal. So this is the example of single inheritance. And here we are writing public. We are writing public means the public functions, the public methods will be public in the child class also. But if there was some protected class, then the protected things will also become protected in this new child class. So ignore it for now. Now we will go for multi-level inheritance. So what happens in multi-level inheritance? When a class inherits from a derived class and the derived class becomes the base class of the new class, it is called multi-level. Means there is some levels, means it is something like grandfather, then parents, then child. You can simply look at this example that we are creating an object of baby dog. Means the baby dog is the child of this dog, and this is the child of this animal. So this is inheriting the properties step by step. So this is called multi-level inheritance. So after multi-level, we will read about multiple inheritance. So in multiple inheritance, there is two parents of a single child. So what is written over here? That in multiple inheritance, a class can inherit more than one class. This means that in this type of inheritance, a single child class can have multiple parent class. So now we will go to the second part, which is hierarchical inheritance. So in hierarchical inheritance, one class serves as a base class for more than one derived class. Means it's something like a family tree. So when you will see that a family tree is creating of the classes, then you can simply say that that one is a hierarchical inheritance. And the next one is hybrid inheritance. So in hybrid inheritance is a combination of more than one type of inheritance. For example, a child and a parent class relationship that follows multiple and hierarchical inheritance can be called hybrid inheritance. So as you can see that this is the example of hierarchical and multiple inheritance. Hierarchical, what was happening in hierarchical inheritance, that family tree like structure was creating. So here you can see a family tree like structure is creating. So hierarchical inheritance is written over here, and you can see that this child has two parents. Means we have already read that when a single child have two parents, then this will be called multiple inheritance. So this is the example of multiple inheritance, means A, F and B. So when a combination is creating, this is called hybrid inheritance. Now we will read inheritance ambiguity. So there may be a possibility that a class may inherit member functions with the same name from two or more base classes. So what is written over here, that is we are creating a child class C, and this is the example of multiple inheritance, that it has two parents A and B, and you can see that both parents have a function in the same name ABC. So if we simply write object.abc, then compiler will be confused that the which ABC is calling here. So we have to specify that we are calling ABC of this A, means this A class. So then no error will come. So these things are called ambiguity, means something when this is the same name of the functions of two different parents. So compiler sometimes become confused. So these things called inheritance ambiguity. So that's all about inheritance. I hope you have already understand this. So now we will learn about polymorphism. Now we will read about polymorphism. Polymorphism is also as important topic as inheritance. So polymorphism is considered one of the important features of object-oriented programming. I have already told you. So polymorphism is a concept that allows you to perform a single action in different ways. Means you are a child of your family, you are boyfriend of your girlfriend, you are someday you will become father of your son. So these things is called polymorphism, that the same person is behaving a lot of nature. That is called that allows you to perform a single action in different ways. Polymorphism is a combination of two Greek words. The poly means many, morphs means forms. So polymorphism means many forms. So this is also written as a, let's understand polymorphism with a real life example. So I have already given you the real life example, that you were a single person and you were acting. I will not say acting, means you are a son, a husband, a father at the same time. So this is called polymorphism. So there are two types of polymorphism. First one is compile time, second one is runtime. So now we will read about compile time polymorphism. Compile time polymorphism is also known as static polymorphism. This type of polymorphism can be achieved through function overloading and operator overloading. I think you already know about function overloading. Function overloading means if there's the same name of two functions, then the compiler differentiate between those functions by the parameters given. So this function overloading is an example of compile time polymorphism. Now we will read about operator overloading. So what is operator overloading? You can see that we are creating two objects of complex type C1 and C2. So this is called a parameterized constructor, means this will call this constructor. But as we are giving the value for the first, so as we are giving the value, so in that case R will be 10 and I will be 5. If you don't give any value, then R will simply become 0 and I will also become 0, because we are giving we have already provided the default value. So now we will read what is actually operator overloading. When we are using this plus operator, then this is automatically called when plus is used between two complex objects. So and plus functionality works here. So this b dot real means the real part of this object B, and complex operator means the normally the C1's real part is used here. So these things are called operator overloading. I hope you have understand it. If you don't understand, then please do comment. I will try to give more easy examples for this so that you can understand it very properly. Now we will read about runtime polymorphism. Runtime polymorphism is also known as dynamic polymorphism. So method overloading is a way to implement runtime polymorphism. So what is method overloading? Method overloading is a feature that allows you to redefine the parent class method in the child class based on its requirement. let comes for the example that we are creating two objects of type subclass 1 and subclass 2, which is O1 and O2. And as you can see that subclass 1 is a child of parent and subclass 2 is also a child of parent, and we are rewriting the function show function in subclass 1 also, in subclass 2 also. So whenever we are calling this show function of object 1, then this will be printed simply inside subclass 1, and for this inside subclass 2 means this line that inside parent class is overridden in this child function. So this is called runtime polymorphism, and this is an example of runtime polymorphism, and this process is called method overridden. So now we will read about abstractions. So what is abstraction? Abstraction is one of the most essential and important features of object-oriented programming in C++. And abstraction means displaying only essential information and hiding the details. So for example, you can say that when we use a class, we always try to hide the essential information in the private part or in the protected part, and we only give access to the other functions of the public part. So these things is written over here. And data abstractions refer to providing only necessary information about the outside world's data, hiding the background details and implementation. So let's understand abstractions in a real life example. So a real life example is maybe like that you are writing a function which you will storing some personal data of your clients or of your employee. So you don't want to give the access of that personal data to others. So you can simply write those functions or initialize those variables on the public part of your class, and other functions like giving the salary on time or your work details, you can simply write it on the public section. So by this you are protecting your private data, your passwords in the protected part or in the private part. So this is all about abstractions. Now we will read about interfaces. So what is interfaces? And interfaces describe the behavior or capabilities of C++ class without committing to a particular implementation of that class. I know it's quite confusing, so just ignore it. Let's read the second para. That is written that the C++ interfaces are implemented using the abstract classes. So now comes what is abstract classes. That is also written here that these abstract classes should not be confused with the data abstraction. We have already read about data abstractions, but this abstract classes is different from the data abstractions. So data abstraction is this concept of keeping implementation details separated from the associated data, that is called data abstractions. So when which is called abstract classes, that is a class is made abstract by declaring at least one of its function as a pure virtual function. So what is a pure virtual function? Pure virtual function is like that when we give all the details of functions, that the return value, if it has some parameters, then the parameters also, but we do not write the code here, the code about the functions. Here we just specify by placing is equal to 0 in its declaration. So this is called pure virtual functions, and if your class has at least one pure virtual function, then you may call it abstract classes. So for example, if a class is an abstract class and it has a pure virtual function, so we cannot initialize any object of that class. You can see it here, when I am initializing an object of class animal, this is given an error because it is an abstract class. Means the whole class is abstracted. No one can access this class. So how to access this class? You can simply make a child class of the main class, and you can simply access this child class or all the details of this parent class from the child class. Means we are writing the full code of this pure virtual functions, and I have already told that pure virtual functions means a function will have its own return type, its own parameters, but we will not write the code. We will just give is equal to 0 in its declaration. So we will write the code in the child part. So in the child part, you can simply call the sound functions, so it will not give any error. So that is for today, guys. I will be back with more interesting videos. So till then, keep coding, keep hustling.